Alright, so if you remember, most of what we've been doing is you're given a function and you have to find the zeros. With these ones, it's the reverse. You're given the zeros and you need to find the function. Don't forget the ones that are, the ones that are listed, I know it's kind of hard to tell the difference of color because they're both dark, but the ones that are written in black is the original problem. It gives you 3, 4 plus 2i, and then 1 plus the square root of 7. Okay, but according to the two theorems that we had, that we wrote down on the first day, if you have this, then you also have this, and if you have this, you also have this, okay, and that works the other way. If you had been given these two to start, you would have also written these two down. The theorem writes it as if you have the positive one, then you have the negative one, but technically it works both ways. So, again, part of the reason the way we write our zeros when we are working the problems is we write them as like x is equal to something, and then we move the stuff over and set x plus or minus whatever it is equal to 0, is so that you get used to being able to do this. So all of these, x is equal to each of these things, and then whenever we want to find the factors, which is what we needed here, we have to add or subtract all the stuff over and set them equal to 0, which is how we got this part. And then we used each of these pieces that are written and wrote them down here, and we started multiplying. So we left the x minus 3 by itself for now because it's just easier to group the things that look similar with each other. So we started with the x term and multiplied it by each of these, and then where we froze was when I started multiplying this -4, and I had started and I accidentally did the -4 times -4 first, so that's where I got the positive 16, and then I went back and did the -4x, and that's about the time everybody screamed and let me know that it was stopped. So somewhere in there is where you probably had stopped writing, and so then we had the -4 times 2i, which I didn't even finish writing because there is. It was like it stopped, so I just dropped my pen and was like, okay, I'm done. So, anyway, so yes, that should be a -8i there. So that's taking care of the x and the 4. So now we just need to do the -2i, and it's obviously going to take me another whole line because I still have to multiply these ones out as well. So I've got -2ix plus 8i minus 4i squared. Okay, and then I'm gonna leave some room so I can like do some canceling here. I'm gonna do it in another color. If you guys need another color, you can, but I'm gonna multiply this other stuff. So I'm gonna like skip some space and multiply it down here, and just know that still everything is ultimately gonna be multiplied together. Okay, I'm probably not gonna be this mean and give you one this hard on your test, just so you know. But I figure if you can do this one, you can do any of them. So, over here we've got x squared minus x plus, I'm going to just put the x in front, but the x squared is 7, and then minus x plus 1 minus the square root of 7, minus x squared root of 7 plus the square root of 7 minus 7. And then again, I'm going to leave some room underneath so I can cancel stuff. Minus the square root of 7 times the square root of 7. The square roots cancel each other because technically inside you'd have the square root of 49, which is 7. And then it's negative because one of them's negative and one's positive. What? So the last part, because I know it's kind of smushed, it's minus x squared root of 7 plus the square root of 7 and then minus 7. But minus 7 is outside. Yeah, sorry, it's kind of smushed together there. Alright, so I would go through and underneath of it, I would kind of cancel some stuff out and just make sure that we're taking care of it, and let's make it easier to simplify it when we go to rewrite everything. Because a lot of this, I mean, you're not going to want to multiply this x minus 3 times everything here and then go through, and this would be like a million times FOIL, and that's just not fun. So we're going to simplify it down before we do anything else. So the only x squared term I have is here, so I can go ahead and write it down. Can y'all see that color okay, or do I need a different color? Okay. It's just a very light color on green paper, so it's just kind of... Alright, so then I've got just x terms that don't have i's in them. I've got this one, I've got this one, and that's it. So that's going to be minus 8x. Okay, anything with ix, I'm going to see what happens. These two, unfortunately, are going to cancel out, so I can just get rid of them. Pretty much, yeah. They're on occasion, well, on occasion maybe not, but because, well, yes, they would. Yeah, I had to think about it, but then I was like, yes, because the signs are opposite, which is why if we were to write them this way, technically speaking, you would see that because it's going to be a difference of squares, but that can be more complicated and signs can get lost, so that's why I just said write it this way. I mean, basically, I just like to do it that way, but it doesn't have to be that way. Yeah. Alright, so we got rid of our ix terms because they were opposite signs. Okay, and it's kind of like Taylor said, technically speaking, your I terms should always go away because of the way the theorem is written. If they don't all go away, then I would go back and check a sign. So then, just our I terms, I've got a positive one and a negative one, so those are going away. Okay, here I need to remember the I squared is what? Negative 1, so this is going to be a positive 4, so 16 and 4 is 20. So that just made my life a whole lot easier there with that one. Okay, and I want to do the same thing with the ones that have the radicals in them. So, we're not done yet. These are technically just things that are still going to be multiplied. This is as hard as these problems get. So x squared is coming down. And then, so that one's taken care of now. So then just my x terms, these are the only two that are just x's that don't have anything else with them. So minus 2x. Now I've got my radical stuff to deal with here. So I've got plus x root 7 and minus x root 7, and that should be all that have that. So hold on, I'm going to underline the stuff I've already dealt with. So these are going away. Okay, and again, based on the theorem, that is what should be happening, okay? Just the square root of 7, okay, we have a negative 1 and a positive 1, so they're also going away. So then we've got positive 1 and negative 7, so negative 6. Well, you're done simplifying. We're not done. So now, I'm going to rewrite this as x minus 3 times x squared minus 8x plus 20 times x squared minus 2x minus 6. So again, I probably would multiply these two first and then save this one for last. So I would just bring this one down again. So x minus 3. So then over here, I'm going to multiply all this stuff through. So x to the 4th minus 2x cubed minus 6x squared minus 8x cubed plus 16x squared plus 48x plus 20x squared. This is not all going to fit right here, and that's really sad. Minus 40x minus 120. Okay, so then I'm going to go through and simplify all of that again, just like I did above. So I've got x minus 3 times, let's see, the x to the 4th will just come down. There's no other x to the 4th, so x to the 4th. My x cubed terms, I've got 2 of those, so that's going to be negative 10x cubed. X squared terms, I've got 3 of them, 30x squared. And then x terms, I've got just 8x left, and then minus 120, 48 minus 40. Okay, and then now you just need to multiply this last x through, and then the number through, and then simplify. So this is not all going to fit on one line, I'm pretty sure, but anyways. Yeah. No. Oh, sorry. I thought you meant, do I have to keep going? I was like, yes, you have to keep going. Forgot Barkley was sitting on the floor. I was like, did she disappear? Alright. X to the 5th minus 10x to the 4th plus 30x cubed plus 8x squared minus 120x. And then minus 3x to the 4th plus 30x cubed minus 90x squared minus 24x plus 360. Did I do something wrong? Okay, I thought somebody was questioning something, so I was making sure. Alright, and then you just simplify it, get all like terms together, so x to the 5th, oh goodness, minus 13x to the 4th, plus 60x cubed. If I add something wrong, somebody please stop me. Minus 82x squared, minus 144x plus 360. And you're done.
Wow.
I don't even remember which problem I gave y'all to do. Are you sure you did it wrong?
Yes, I did it right because I have working next to word I. You cannot have that. So I definitely.
Yeah, your biggest x term should be an x to the 4th also. Okay. So remember, however many zeros you start with, that's what the number of your biggest x term should be. So I had 5 zeros to start with, so this is x to the 5th. So that's another way to kind of check and make sure you're doing this correctly. I thought you were saying do problem 66. I was like, Tabitha, if there's a 66, it's a word problem. Actually, 66 is a matrix. Alright, let's do one more problem. Okay, the instructions look a little different because it says to classify the zeros. It says to tell you how many are positive, how many are negative, how many are imaginary. I'm not asking you to do that. I'm just asking you to find them again. Okay.
If we're finding zeros again, we're doing the thing we did yesterday?
Yes, we're going back to that. Yes, we're going back to what we did on Friday, yes. I'm going to do one more problem like that to make sure we're good, and then I'll give you guys like one more problem to do, and one or two more to add on to what I already gave you.
I told my mom that, and she starts explaining it to me, and I'm like, Mom, I don't need you to explain it to me. I'm telling you what I'm doing.
See, I figure you have a little bit of an advantage. She can do it.
But my mom has to stop. My mom can add. She can do numbers.
Let's do 38. Keep it semi-simple. Semi-not. H of x is equal to x to the 5th minus 3x cubed plus 8x minus 10.
Oh, thank you.
What is the first thing I should notice? I'm missing x to the 4th and x squared, so I would write in 0x to the 4th and 0x squared so that when you get to do your synthetic, you don't forget that.
Wait, wait, wait. 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 W
Alright, so I need to start out finding zeros. How would I go about doing that? We did not. The last problem was the reverse of this. We're now finding the zeros. In the last one we were given the zeros. Hi. Yep. Alright, so how do I find which ones are actually to what? Okay, so we're going back to graphing because we got to figure out which ones might work. Correct. Or you can just turn them off. This graph is interesting.
Why does it look like this? See? Oh my god, I'm so wait, I haven't even typed in the phone yet.
Problem is very interesting. This might be one that we won't be able to do. Yeah, this might be one that we can't do without, yeah. Well, it's hard because it doesn't tell me what all the zeros are when I'm just looking at it because that's not what this section asks, this part asks for, so we may just go back and do one of the ones that we didn't do yet. It's not, well, yeah, but that won't work. This problem is weird. Okay, let's just go back and do one that we can do. Yeah, just get rid of that problem. We'll go back and do 16. That's what we're going to go back and do 16. Alright. So, new problem, number 16. Okay, as long as y'all remember that they're plus or minus, once you get to this section, I don't really care if you write plus or minus. Just remember that it is plus and minus. Okay, if I ask you to, like, on the last section where I ask you to write out all the possible ones, and I said, but, like, don't find them, or something like that, like, don't find what they are, you do need to write the plus and minuses, but other than that, you can just know that that's what they are. Or write a note at the top that says, like, all are plus or minus, or something like that. That works. I don't really care. I know what you mean. Alright, does everybody have these written down? Okay. Well, once you get there, there's a fuzz. There's, okay, there, it went away.
It's perfect.
That's good.
No, it's not. No, it's not perfect.
It moved.
You know, it's like this. Oh. I already did that. I'm past that step.
Oh. Well, it's like, that's not what mine was like. Wait, I'm trying myself.
Then you do the box thing. I already did it, and it looks whack. I don't think you can do this.
Nope, we can. How many zeros am I going to have when I'm done with this problem? 4.
I know that. I wasn't even here.
Okay, so I'm going to have 4 zeros. So when I'm done, if I don't have 4 zeros, I know that I did something wrong. Okay. We're saying we're guessing -3 and -1.
Wait, Sarah, can I bring my
Did you zoom box it? You don't have 2 intersecting lines. You probably just boxed it differently. Alright, so we're guessing -3 and -1, so how are we going to check them?
synthetic? You have -3 in the little box thing. 1, 4, 7, 15, 12 on the top. Right there, heart. So if we like put, say we guess -2 and -1 said -3, -1, like does that mess up everything?
Yeah, because I mean,
So if it doesn't come out to 0, something's wrong.
yeah, if it doesn't come out to 0, it's not a 0. Okay, so you guys should be able to do your synthetic at this point.
Can you use the numbers from the first one?
Wait, what do you mean use the numbers from the first one?
Like you use the numbers from that.
Yes. So remember this started as an x to the 4th term, so now this is going to be an x cubed term. So,
This makes sense. I think this was on the video I watched.
yeah, pretty much the only thing I think you really missed was the zeros. Like, we did another problem like this on Friday, but you should have pretty much had the general of this. No. Anything raised to the 0 is 1. Times 0 is 0. Okay, so remember, we're just writing this like this so you get used to seeing it. So when you do the problems that we just finished, you're used to that. Okay, so now I'm left with x squared plus 4 is equal to 0. No, it just ended up like the one we've done before. I don't think we did this one. I just looked and I saw 14 and 18 that we had done. I don't think we did 16.
So basically, at this step, can you take that 1 with 8x squared, whatever it is.
Whatever numbers are left here, you just write them down as like, this is x squared, this is x, and then this is the constant term. If that wasn't a 0, you'd have to factor it. Or use the quadratic formula. No. In this case it is though, so I don't have to worry about it. Okay, so how do I solve for x? This is pre-algebra. Subtract 4. Yes. To where? Hold on. Got a question. From right here. From what was left over after the second synthetic. This is the x squared. This would be the x term, and then this would be the constant term. Because it goes down, because this would have been x cubed, and then, so now that has gone down to an x term because I keep doing synthetic on it. You're not squaring it. You're taking the square root. Well, I will eventually get to. Because it's a negative under the radical. So then now this is x is equal to plus or minus 2i. So all my zeros then are -3, -1, 2i, and -2i.
Wait, that's the answer?
Yeah.
Oh, no. Can we do, like, the other one? I have no idea how to do that.
I think number 18 was that way, so I can go over that one with you, because I'm not going to, like, go over that one again for the whole class, unless everybody just wants to do another one. Just kidding. That one didn't come out that way. I don't know if there is one that's going to come out that way that we've done. And it's hard to just know what's going to come out that way.
What was that? Like, what happened?
I don't see one that came out that way, so there might not be one that comes out that way. Because when you take the square root, it's plus or minus. Yeah. Because remember, if you have this one, you automatically have this one also from the theorem.
Is there going to be one like that on the test?
Probably not, because there hasn't been one that's shown up in all the problems that we've done, so most likely no. But if it was, then basically, if you had another term here, then you just use the quadratic formula, the negative b plus or minus the square root of b squared minus 4ac all over 2a, and whatever that comes out to be is your other ones. It'll usually come out nice to be something that you could do. What? No. Oh. You just start with, like, this is what we did the other day. You just start with whatever the zeros are, and then you just set x equal to that, get them by themselves, and then multiply them. I can go over that with you later. Okay. From what's left down here. Yeah, if it was like 3x. Well, it might be something that could be factored. Okay, so if it can be factored, you just factor it, and that'll give you the other two. But if it's something that can't be factored, then you would use the quadratic formula. No, the answer from the quadratic formula would just be your other zeros. But we have not had one like that, so you will not intentionally have one that does that or anything like that on the test. Alright, so trying to see what problems I gave you the other day. Does anybody remember what problems I gave you the other day? Okay. Hold on. I'm gonna... Can you repeat that so I can write that down? Okay, so that was what was due today. So the new stuff that you have, and you've got over 20 minutes to work on it. So I'm not going to give you a ton more. 19. 25, yes, and 29. Okay, so 25 and 29 are the ones where you're given the zeros and asked to find the function. 19, you're given the function and asked to find the zeros.